Good morning to you all. I remain Edward Wasurum, the tutor in Edward's Academy. This morning I will be teaching you how to estimate vector autoregression model. Vector autoregression model is also known as the VAR. VAR is estimated when the hypothesis of no cointegration is being accepted. That implies that VAR is estimated when the Johansen cointegration text establishes the absence of any cointegrating relationships among the time series that are so investigated. In the presence of that, researchers actually decide to perform VAR. VAR enables you to actually know the contemporaneous relationship among these variables, because in VAR model all the variables are endogenous in nature. The endogenous nature of those variables in the VAR model implies that you only try to ascertain the contemporaneous relationship that exists among the time series data so requested. So this morning I will teach you how to estimate the VAR model. I'll teach you how to actually ascertain the impulse response functions that is required to actually know the shocks and innovations inherent in the VAR model. I'll also teach you how to estimate the variance error decomposition function of the AR model. So stay tuned as I adopt a study approach this morning. I'll be looking at how capital market variables affect economic growth in Nigeria. And let me go back to my eView portal to teach you how we derive VR model using eViews 9. The reason why I decided to use eView 9 in this study is that eView 9 has proven to be more simple to understand and most of the time, to me, more efficient than others. So this is my eView worksheet. I've already loaded the variables in my eView worksheet. From my left hand, you can see this is the inflation variable. This is interest rate variable. This is the market capitalization index. This is the number of deals in the stock market. This is the variable real GDP that captures economic growth. This is unemployment, and the value of transaction in the markets is being also presented here as veterans. So given the first condition that before you perform the VAR model, is expected that all your variables were stationary after first differencing, and that the Johansen cointegration result actually gives you the absence of no cointegrating vector in the model. That means that all hypotheses of no cointegration have been accepted. So given that condition, we now proceed to actually estimate. The first thing you are supposed to do is to actually identify the lag length of the model. The first thing to do is to identify the lag length, and for you to identify the lag length, you go to quick. From quick, you maneuver to estimate VAR. Then you specify your variables. The dependent variable in my model is log value of ROGDP. You give a space followed by the log value of market capitalization index. You give a space followed by the log of value of transaction in the market, veterans, value of transaction in the market. You give a space, then followed by the log of number of deals and deal in the market. You give a space and added interest rate in the model. Okay, without changing anything, we now click OK. It will be exposed to a normal VAR output, but this is not where we are going to. You now proceed to view. From view, you maneuver to lag length, lag structure. From lag structure, you maneuver to lag length criteria. You allow the lag specification to be where it is. You click OK. You'll be exposed to a result that looks like this, where the 5 information criterion will specify the appropriate lag for the study. You now decide on the presence of any of these information criterion. Look at it. There is always an asterisk attached to the values of the information criterion. If you trace them horizontally leftward, you will now observe that the main information criterion lists LRO, FPE, AIC, SIC, and QA. They advise that the best information criterion for the study is the lag length 2. So since the lag length 2 is the best lag for the study, we'll now go back to estimate in the results. We move back to estimate in result. We allow the lag to become or to remain where it is without changing anything, because we are doing unrestricted VAR. You click OK. We return back to the previous result we had. But if you look at this result, I told you previously that in the file output, all variables are endogenous in nature, and being endogenous implies that the variables are independent in nature. And if you look at this result, we have each result of each of the variables. They are all stated. Each of the variables has its own result from lag 1 to lag 2. If you go down, you observe that each of the variables, they all have their own result. They have their R square and their constant values, and this is how ordinary VAR looks like. But if you look at this VAR do not have a p-value. This VAR has coefficient, there is a standard error and a t-statistic, and most of the time it's not advisable to actually interpret a result without a p-value, because some people find it very difficult to actually interpret result without a p-value. So I'm going to estimate a VAR result now that actually will produce the probability values of this result. So to do that, I will want to actually freeze this result to have it handy, because I will be comparing it with another result that I will actually estimate with a p-value. So this result will be kept here for comparison. So this is my original result. So for me to actually generate the probability value or values of each of these endogenous variable, I'll go to view. From view, I'll maneuver. I'll go to proc. From proc, I'll go to make system. From make system, I maneuver to order by variable. From order by variable, I will only highlight and copy the first model, which is actually relevant for the study. I'll go to quick again. I'll maneuver to estimate equation. I will paste the specification are so copied from make system. I will click OK without modifying or changing anything. I will click OK. Once I click OK, I'm now exposed to a different result, a newer result that has probability value. This is the new VAR result, and if you compare this new VAR result with the old VAR results, the results are the same. The only thing you are not going to see in the old VAR result is the probability value. For example, C1 in the new VAR result is equivalent to the lag value of the RGDP, and the coefficient is 0.200232, the same 0.200232. The standard error is 0.198993, the same standard error 0.19899. Then if you look at the t-statistics, is negative 1.0016, sorry, negative 1.006226. The same thing happens. So if you look at the result, they are very, very similar, just like this other one is a little bit approximated. So this is how you actually estimate your VAR results with probability value. We can also infer short-run causation in this VAR results. So brothers and friends, stay tuned to my channel. In my next video, I'm going to teach you how to actually infer short-run causation in a VAR output. Thank you for staying true to my video, and God bless you.